Okay, last class we were discussing about how to give a structure to a menu that is better for helping the user in finding the right sequence command. And the one result about that is if you present the user with a few choices in each level, that will be produce a decreasing number of error. If you increase the number of choices, it is much better. And I discussed that I don't like the new trend of user interfaces in which, in order to not confuse the user, the interface presents only few actions for page. And another way of improving the efficacy of a menu is to give a clue, an understanding of what is behind the menu itself. You have a menu with the news, finance, entertainment, traveling, whatever, and there are some cues about what is behind this item. News is about weather, politics, and so on. And some experiment demonstrated that this kind of arrangement will produce a different number of errors. It reduces the errors, having an understanding, a cue about what is behind this single item. And according to that, because I really hate this kind of situation in which for setting the printing of my Word document, I have to remember all the possible configuration. There is a preset setting that I can use, but just something that I saved somewhere. And I have the option for the layout, for what else, I don't remember. Here I have only the possibility of how many pages to print together, and if I go to print 2 sides or not, and something like that. What about the other options? And my suggestion for Word developer is just to modify the menu in this way. Present all the possible options. It is a basic principle of human-computer interaction. Recognition rather than recall. You are not to remember what is behind here. There is room for that. So I have 3 choices here: layout, paper handling, a cover page. And the layout has been selected, and here there is the interface of this. What about paper handling, a cover page? Paper handling is about the page to print, the page order, scaling the image, or whatever. Cover page is about printing or not the cover page, the type of cover page you want, and so on. So simple. Why they don't do that? And this is something that I feel very often teaching these stories. Some of these ideas are really simple, like the contrast of color, or just improving the efficacy of a menu, just putting some pieces of information about the linked items. And these simple ideas are totally ignored by people. So I push on you during your exam, remember these simple ideas. Tomorrow, together with Marco Angelini, we will present a description of what it will be the structure of the exam of this course, and what we are expected, what we ask you to present in that exam, and what you have not to forget. But let's go to deep a little bit in this idea of guiding the user. Again, as I said the last time, we are in the between of InfoVis and human-computer interaction. The idea is how to design a system that gives indication of the direction in which you can go. Here, if you are here, you are somehow lost. You have to explore each of these list to understand what there is behind. Here, there is some indications about where to go. And this is the idea that Bob Spence called the scent. Scent is, in Italian, profumo, traccia, pista. Think of a dog that is smelling some smells for understanding where to go, what to follow, to answer the question, where can I go from here? And this is where, not when, I would correct it. And where can I most beneficially go from here? Not only where I can go, but where I can go with getting the most of the advantage for me. And this is called the scent by Bob Spence. It is the perceived benefit associated with a single movement that is evaluated through one or more cues. I remember that we have the notion of single movement, a single interaction, clicking a button, clicking on an arrow, or something like that. That corresponds to a movement in the information space. And we need some cues, some indizi in Italian, for getting ideas about where to go and where to go with some useful result. And this, the scent is exactly what you perceive. It is not a simple idea because it is an high-order cognitive process. You have to do some reasoning for that. And it depends on your internal model of the information space. What is the mental image that you have in mind of the data you are exploring? And moreover, it depends on the strategy that you are adopting to carry out the task you are interested in. And just I provide some example that, no more than that. And this is the relation that exists among sensitivity, residue, and scent. The question we have in mind are where to go, how to go there, what there is behind of the single next step, or what is very far from us, the distant content, and what's my benefit in doing that. So you have the remote content to explore, you have a single movement and a single interaction for moving, and you have to encode it in your interface, taking in account the residue, what is the behind your situation, and you have to encode some cue, indizi about what is the remote content, and also giving some cues about the sensitivity. Sensitivity is the combination, the single movement, a single interaction, something that helps you to understand how to act on the interface. Having this in front of you, there is the human interpretation that looks for sensitivity cues and the residues, and it evaluates the benefit of that movement. That is exactly the meaning of scent. And scent is hard to implement, it's hard to encode. Unfortunately, that will be basically an abstract idea. You can try to do that, but however, I show you an example, a nice example of this. The example is about interpolation. You have some points on the plane, X and Y, in which you have computed or measured that points. And basically, you want to find a simple mathematical function that is approximating these points. You know what I mean. And you have a statistical package that helps you in understanding the coefficient of this equation. You can have a different kind of approximation, and your formula, the y is basically a constant by first order combination of variable, and you have the combination of two variables together, and till the third grade of the equation. And you have a lot of possible combination of that. And what are the significant terms? X1 by x2, x1 by x3, and here the information space you are looking at is the definition of the formula to find out the coefficient and the right terms to put inside the formula. And we are thinking about not expert user. And this is the interface. It is old-fashioned, but I still like old-fashioned stuff because in this way we can concentrate on ideas instead of being disturbed by technology. The idea here is to help the user to find the terms that he can include in the question for approximating the points. And each square represents a term on the question. This is first order term. These are second order terms. This is third one, and so on. And the single movement and the single interaction are encoded in the box. You have just to click on with the mouse with the circle to include the term in the equation or to exclude it. If the circle is white, that means that the term is not included. Clicking on it, you are going to include it. The other way around, if the circle is black, it means that the term has been already included, and clicking on it, you are going to exclude it. So that gives you an idea what are the terms of the equation. Are just these three first order plus this of second order. And the sides of the circle is encoding the benefit, the improvement of the formula that you can have either including a term or excluding a term. So in this way, basically, we are trying to encode the shunt in the interface. Everything is here. You know what to do, single interaction, single movement, and the sides of the circle is a simple cue about the utility of this step. So if you are in this situation, what are you likely to include or exclude? It is really easy. You look for the big circles, and I will go for this. I will go to include this term. I will go to exclude this one, and maybe this one as well, to simplify the formula. But I want to include this one and this one. And each time you click on a term, the formula is updated and the circle will change. It's not a static situation. So there is no direct strategy, but you are guided in that. And this is a nice example of shunt to me. What I don't like of this interface, the circle. If you remember, the circle is not area, and also circle are not very good in giving you the perception of quantity. Maybe that the bar inside the box will be more suitable for that. But the other way around, a circle is a nice cue for acting on it. It suggests the idea of I click here, while a bar is less likely to catch your attention for the interaction. However, this is an old-fashioned example, but I think you got the idea of what the shunt could be. Here we have another idea. Very simple, very effective. I never saw it implemented. Just you have a menu about some people, employees in a company. Employees are split in different categories for marketing, sales, research, administration, whatever. And clicking on here, you get all the people in administration, on the research, and so on. This bar length gives you the idea of the residue. How many people are here? You see, you can perceive quickly that the sales and marketing are dominating the story, and the search people are in the last position as usual, and administration are in the middle. Very simple idea. Why not to use it? And the general question you have that is very common when you are traveling on the web, where is my position? Where am I? And where can I go from here? How do I get there? What lies behind? Where can I usefully go from here, usefully? And very common, where have you been? I want to go back. It's very common that if you go for a very strong interaction with the web, you can lose some pages. You want to be back to some pages that you visited before. You are not able to remember the path that brought you there. This is more or less the same that you go walking in a wild zone. The physical movement and the browsing the web are very similar in this sense. And the typical idea is to use breadcrumbs, briciole di pane, as a way to remembering what you did. And you can have this breadcrumb describing the path you did or the location that you are visiting. Here is an example of a path. You are representing here the steps you did. So this is your path in the information space, and it represents the recent location and the single interaction. Here is your current location. You're here, and you can go there. This is what are the next links you have in front of you. And this kind of breadcrumbs facilitates what is called the selected retreat, in the sense that you're not going back one step. Sometimes it's tedious. Back. You can jump directly to the initial part of your traveling. This is much more efficient. And you are familiar with that. We have all the browser now recognizes the importance of this idea, and you have an history of the page you have visited. You have an ordered list of the next step you did. The idea is to help this kind of reasoning to answer this kind of questions. And while for the web now is so common that you can think, oh, but I am talking about something that you already know, nothing new. I do totally agree. But if you define your new system, a visual complex system, you have to somehow give the same kind of facilities to the user. And you can have also location breadcrumbs for having the structure of the site. Here is the path you followed. This is your actual position. These are the next step you can do. And here there are other information, other pieces of information about the part of the website that you didn't travel that can bring you in the same position. This is very common for representing the web structure. And the typical breadcrumb you have is exactly this. And you have the list of your steps you did in browsing this website. And you can go for selective back. Instead of doing back, you can just click here and you will be in the home of your path that sometimes can be very, very long. Now it is something that you have for free, and it is something that everybody knows. But before then, that it was not common. This is some research that has been done in 1990. they experimented also with the menu. This is not common. For instance, you have a menu with for movies, and you can browse this menu. You know what I mean. In the end, you are in this position. You get this situation, and you want to be back, and you don't remember what you did. If you're navigating a complex menu, not complex, a deep menu with the 3, 4, 5 steps in the ascending gate, you don't remember what you did. You can have also in the menu a selective retreat. You can be back to entertainment, to the leisure, to main menu, exactly as here. You can do that one step at a time or directly in any point of this path. But what is amazing me now that this idea is still, this is implemented in any browser, basically. This idea is still a research activity done a long time ago, 30 years ago, where we have 50% of improvement in that. And it improves your interaction, but no one is implementing it. Let's remember something about what discussed as a passive interaction. If you are observing a complex system, a visual analytic system, you got last week some complex examples about information, cybersecurity and information visualization and visual analytics for cybersecurity, attack path, vulnerabilities, whatever. And if you are using a complex system, you spend a lot of time not interacting with the system, but just looking at it, because you are observing the screen and you are being involved in high cognitive process. I said that a long time ago, and I said that I say it again. Visual analytics, visualization is not necessarily something easy to use, not at all. If the example you got the next week, the last week, are complex example. The training time for the user is not trivial. You cannot pretend that you just open the interface, you are able to use it in 2 minutes. And also when this is the first problem. And also when you are familiar with the story, understanding the pieces of information on the screen, comparing different sides of boxes, looking for the colors, encoding numerical values, it is a high cognitive process, and it requires times. And you stay in front of the screen, and this screen is not necessarily static. Static display may be just because they are just answering a single question, a specific question. If you remember the beautiful Miner's map about the Russia, Napoleon, this is just one question to tell the story of soldier and fight, whatever. But this or it is something that you did, interacting, acting some analytics or some visual interaction, and the screen change and you observe the new situation. You are passively interacting with it. And here there is an attempt to model how human beings basically focus the attention. The example is that you are in a library. You are looking to a bookshelf, and you're looking for something about cognitive psychology. We're talking about that. And this is the typical way in which you interact. The first thing you do is to get an overview of the story, the pink area. You get all the big picture, and after that you focus on a sub part of it. It is a region containing books that are about psychology, and finally you get the exact location that are concerned with the cognitive psychology. And you do that, you do the same in the supermarket when you're looking for something to buy. And this is also, I would like to comment that to remind you that the part of the cognitive aspect of the InfoVis and visual analytics is still not clear to us. While the research got nice result and useful result, actionable result for perception, colors, blindness, contrast, and so on. I showed you a lot of story about that. How to use these models. These models are less precise. They are more speculative, and to apply them in an interface is not so clear. So I still think that this is something interesting, but I still think that we are still far away from having some result that you can use in practice in some sense. And you can have not only static display or display that you produced by your interaction, you can have a moving display. You stay passive, but the information is continuously updated. For instance, here we have a time sequence of the rate change between dollars and whatever, euro and dollars, that is continuously changing, and you can observe that, and it is data driven. You are not controlling the motion of the information. Or sometimes you are interacting with the system. This is an example from an area that is still a not area of research, controlling determining the correct parameters for complex algorithm. Sometimes you have the algorithm, this algorithm have a lot of parameters, constant, and that you can change, and that affect the behavior. And the idea is that you can have a display in which you have some information about the evolution of what you're observing, for instance, the algorithm. And here you can have this is just evocative of looking for the discrepancy between what you want and what instead you obtained by your actual implementation. You have all the parameters in front of you. You should have also the name of the parameter, the value, but this is just evocative. And you can adjust each parameter, and you can have some control, like the volume of an amplifier, to go to the next step or going back. In this way, you can change the story. You can be back, observe what happened. You can change a parameter going forward and backward, and to see how your parameters are influencing the story. All that can be done also for a teaching purpose, understanding purpose. You want to observe how k-means work, and you can observe how the clusters are performed, are computed across the different iterations. You have no parameters at all, but maybe you can change the seeds of k-means. However, this is called a moving display, which have some control about something, parameters or initialization or whatever. And you can have here a control. Here it is data driven. Here instead is user driven. You are asking the system to go the next step. And here the exploration, the information space is the flow of the algorithm, of the process. Or if you remember the nice old-fashioned coffee shop presented by both Spence, you have a display with advice, and this is involuntary browsing. You are not doing nothing. The images appear, and sometimes you are involved in it. It is very, very common in this moment, something that disturbed me, I think also you. If you go around to get news on the web, you are continuously exposed to advice that they are really invasive. I think that someone has to study to get a taxonomy or the way in which they interact in your text, because they cannot cover the text you're reading, because the purpose of your browsing is to get news from the web. So if they cover the text with advice, you are not able to satisfy your task. But they are trying to go, you know what I mean. They are on the screen, they are on the bottom, in the middle, they just a little bit invading your reading to attract your attention like this, to stop reading the news and start to go for publicity advice to buy something or whatever. So this is story that time would be considered the science fiction. Now it's the reality, the everyday story of our interaction with the web. And of course, all this kind of interaction that I discussed till now are not enough. They might be compound together to accomplish complex tasks. And so, for instance, so you need a mixture of interaction. For instance, you are dealing with a large data set. You can have a stepped interaction to locate the portion of the data you want to explore. And after, you can have continuous and passive interaction to explore the subset. Once you got the subset, you can stop and just look at what you have in your screen, or you can have some filtering action to continuous to see the details, the data. Or when you are controlling an algorithm behavior, you can observe the steps in a passive way, but you can step in with your interaction to change the parameters. And I don't go again with the video. I showed you this example from Bob Spence about the continuous interaction, and to find some zone of interest for the engineer to design the pieces, the shape of the lamp that is satisfying all the limits on the stress. But I want to show something more. This is interesting, but this is a little bit far away from the idea of visual analytics in general, but it's specific for engineering, mechanical engineering. If you are in the production, in a real production, you will never get with an exact manufactured item. You will have some tolerance about that. And here, in this, you see, Bob Spence was using the scatter plot matrix as plum with the stress combination of this. We have this S1, S2, S3, S4, and here in red you have this is a better color in my opinion, because red here is associated with the points satisfying all the performance limits. I should have used the green for that, not red. However, here red means good. And here we have represented the physical uncertainty you have in manufacturing something. And of course, you have to stay with the square within the red zone to be sure that the line of production will produce all items that will be in the safe zone. But you can extend this notion of physical uncertainty to statistical uncertainty. You have the confidence interval of your result, and if you are doing some statistics on the data, you can use this kind of visualization for making visual how your This is your point, but here this uncertainty you have around about the real values. You are using the statistical data. We already discussed this one. This is a modern story, but it is the same story of Bob Spence's idea. Pre-computing everything and allowing the user to browse the space of the result. And last but not least, we have the dynamics of the interaction. Well, what I mean with the dynamics? I mean that you execute an action, you interact with a single interaction, single movement, and the world that is your screen basically move from the old view to the new view. And this is the change in the world. The normal cycle about the user interaction with the world is about changing in the world, but basically what you see is in a visualization system is the changing in the screen, and an old view is replaced by the new view. And I discussed several times, long time ago, about the kind of blindness you can suffer in this change. With the change blindness, something change you're not noticing that, or you have inattentional blindness, you're looking somewhere else. Something change where you are disturbed, distracted. And you can use animation for that. Think of this, you have this situation that are representing some values for different country, A, B, C, D, or whatever. And the size of the circle is representing some value. And you do some calculation and you have this new result. It is a very good idea to present the user with an animation showing that the fact that A is decreasing, C is slightly increasing, D is decreasing as well, while E is increasing a lot. And the animation will convey that in a very nice way. And it's not a bad thing to do because it is free in D3.js. I don't know if Marco Angelini already discussed you this story, but it is a very just an option in a parameter in using the library. So it's very easy to animate something, but please do not abuse of it. I had to fight against my students in thesis to avoid the use animation everywhere with no reason, and I wanted to show you an example of that. Let me go there. No. Here it is. This is somehow related to to the prototype that Graziano Basilli showed you. It is a network, a computer network in which each node is a computer with the interfaces on the network, the connection. There are some pieces of information about risk and so on. And this network is located. This is the topology of the network. It is subdivided in subnetworks, and you can see the topology or whatever. And this structure is computed by a sort of simulated annealing. And the point is that the student that implemented this interface, each time think that it is I'm not able to produce the story. Okay, maybe. Okay, I don't care about that. Oh, okay, it is coming, I think. Now, this is a problem of that Chrome is not able to read from the disk. Firefox should be better. This is the idea. That this network is computed by simulated annealing. If you want to understand how simulated annealing works, this is a good visualization with animation. You are observing the algorithm, and maybe you can have some control on it. You can go during the execution of the algorithm. You can have the step controller that I discussed it before in a very abstract way. You can slow down, you can change the parameter. This is really nice if you want to observe how simulated annealing works. But in this case, I want just to see the network structure. So having this animation is totally useful, not useful. And it's confusing the user. You want to see this, the network, the computer, the network interfaces. So it's much better to have in this part of the story a progress wheel. Never leave the user without understanding what is going on. So if it takes time to produce the network, having a wheel here that gives you the feeling of that there is some elaboration in progress, but having this drawn here with this animation makes no sense. But that it is for free. So the person that implemented this system pushed the button for that, and I was not able to stop it. I think you got the idea. So, not abuse of it. And that concludes the part of the interaction. And this is basically what we did in our story. We started from some techniques that are well done, well understood, for representing single value, two values, three values, multi-dimensional data. And I discussed different possible solutions. You have some concept about the change blindness, using the right values, perceptual issues. I discussed a lot of that, brushing, interacting, and so on. And we have something about the presentation, how to adapt what we did in representing on the screen, scrolling, zooming, but also having distortion. Zooming, panning are the basic story, but you can do something more. Rapid sequence of visual presentation, using a trade-off between space and time, always presenting an overview plus details. I really hate the situation in which you are lost in the image because you have not an overview of everything. And the last part, less formal from some sense, but still useful for helping you in designing good interfaces, is about interaction. And basically, with this, we conclude our theory about InfoVis, visual analytics. We discussed the different visualizations, different techniques, some perceptual issues about that, some technique for presenting the visualization, and I did a clear distinction during the classes about distinction between simple visualization and visual analytics, the interaction between visualization and analytics, computation. And I stop my sharing here. Oh, no, I don't need that. I can change my presentation. This is an attempt to give you an overview about social networks. Okay. Basically, I do that for two reasons. One is because visualization for social network is going to be a complex and challenging story. And also because that might be a suggestion for your exam. Tomorrow we will discuss the structure of the exam, the choices you can do. But one thing that is the starting point of your exam is to make a decision about the data. You are going to have an exam based on some data. And I really like the idea that you select some data that you like. Because if you do some analytics, some visualization, something that you are in love with, you will be more productive. If you do some work on something that you don't like, your enthusiasm is low, and the quality of the result will be low. So social networks can be a very nice field in which you can take the data for the exam. But I present here basically a story of this. This is nice because there is an evolution that is charming, because something that today is totally well known, a long time ago was just pioneering the field. And the other point is to present to you some references. You can follow the. I will put these slides on the web. You can follow these links, and in this link you will have a lot of additional pieces of information. Maybe just a moment, I change my sharing. I go to the desktop so I can easily follow the link. There is a paper about Freeman that is called Visualizing Social Network. You can go for getting that paper, and there is all the story behind it. From this paper, I took the content, part of the content of this class, and there are some books around. Again, I took some content from here, but it's just a part of it. If you are curious, you want to deep the story that I'm going to present, you can have here more additional pieces of information. And the other is a very deep story about the graph metrics. If you love a graph network, basically, there are a lot of measure you can do on that. Some of that we never know, some I know. And if you go there, you have a lot of definition. It is about the graph theory, and you have a lot of the diameter of a graph, the number of cycle, and a lot of maths that you can do to find the sub portion of the graph. And this is interesting because if the graph is representing something that you are looking at for doing some analytics, some metrics, I will show you some example, will produce semantics, exact semantics from the data. But I will not discuss that because just discussing the formula is really boring, but it is a nice source of pieces of information that you can use for analytics. Let's define what are the goals of social network analysis. Basically, what are you talking about? You're talking about Facebook. We're talking about tweets, or everything that is social today. And you're looking for cluster. You have actors, people involved in the story, and sometimes they are strongly linked. You have social groups, or you want to derive look for some path in a graph, or you can want to spot some actors that have a special role in the network. Maybe people that are linking different groups, And you look, as always, you look for outliers, cycles, whatever. This is the idea. But this is intended to work on a social network. And how do we visualize a network of people, of interaction? The most common solution is a graph. We have points representing nodes and are the actors. And we have lines between nodes representing the social interaction, likes, dislike, friends of, or whatever. And again, here we have some example. Definition, some I will use it in the slide later on. Or, and this is less common, we can have an adjacency matrix in which rows and columns are actor. Typically, the matrix is a squared matrix, and we have in the intersection some numbers or colors that represent the interaction. The matrix may be symmetric or asymmetric. Maybe that the sentiment you're representing in the matrix is not symmetric. Love, for instance, likes, for instance. And you can have also different value. 0 meaning nothing, 1 meaning positive, less 1 meaning negative, and so on. And here we have some example of this matrix. The matrix is really compact in representation. Here we have some example, old-fashioned. Here we have direct edge. Bob likes Carol, Carol likes Ted, and Bob and Ted likes each other, and so on. Here you see that Ted is an attractor. Everybody here basically likes him, while Alicia is alone. No one likes her. And this is the kind of specialized actor I was discussing before. People that has strange behavior, a specific behavior, not strange, specialized behavior. And you can have disconnected graph with the link in between. We have a cluster in the graph that represent some kind of semantics. And you can have, if you remember, I discussed a lot about radial drawing, in which you arrange node on the circle, and that you can have a more compact representation of the links. And here there's an example of how to map a matrix in a graph in a matrix. Here there is the relationship of likes between Bob, Carol, Ted, and Alicia, and Alice, and you can see that the matrix is not symmetric. You put in 1, Bob likes Carol, Bob likes Ted, Bob is not liking Alice, but if Bob likes Carol, it doesn't mean that Carol likes Bob. In fact, it is. So this matrix is not symmetric. It is called the adjacency matrix. And here there is the sigil, the capital letter of the name of the people, and that might be really effective. And I want to show you an example. Tomorrow we will have some additional story about network medicine that is a fascinating domain. My group is working on it. I have several researchers doing. I did this what you're looking at now. It's something that I did by myself, and here what do we have here? We are discussing about the interactoma. What is the interactoma? Is a complex network that is being built in the last years by research in the medical domain, observing the possible interaction between genes. or protein. That is more or less the same thing. And basically, here you have on the matrix, this is the list of all the genes you are observing. And if there is a square in the middle, an orange square, means that that gene interacts with the other gene. Here we are observing 200 genes. This is a 200 by 200 matrix. We have 197 interactions that we observed here in this way. But I go for the demo, but I want to explain before the semantics of that. And please remember this, the way in which I am proceeding. I am starting with the static image. I have the prototype behind me. I will show very soon the prototype working. But the point is that if you are explaining something, you want to discuss something, and when you will present your exam, you will have a PowerPoint presentation for doing that. And the PowerPoint presentation is static, and it is the best way to explaining your encoding. This is the representation. I am representing a graph here. These and these are the nodes. And the square in the middle means that that gene interacts with that gene. There is a link between them. And we have two kinds of interaction. In blue, we have direct interaction. In orange, we have two-step interaction. A interacts with B. B interacts with C. A and C are connected somehow. We are exploring this here. The blue one are the direct interaction, while the orange are the interaction to one first level with the path or distance two, assuming that edges are transitive. It's not always the case. I'll show you the demo very quickly. Here it is. Let me reset the story. Okay. We are observing here 200 genes. All is a portion of the interactoma. And now you can see how the interaction helped me. Here we have the genes in a scatter plot. If I select a single gene, I have here some information about the gene, and you see a coordination between this window and this window. Passing over here, I see the line of this gene. I see all the interaction it has. You can see this is the gene 472 or whatever. They have some code, and you can see all the interaction on the single row. And I can move here, here, here. I can select, if I remember well, more than one, and I can observe here the possible interaction they have. And here, let me refresh. I don't remember how to use it. It is something that we did 4 years ago, something like that. Here, the two views are not coordinated in both directions. We will discuss that tomorrow, but this is something that is mandatory, having at least one example of two views symmetrically coordinated. I touch something here, and that affects here. The other way around, I touch something here, and that affects here. But in this case, it's not possible. It was not, will be not implemented. And here I can just observe only the two steps interaction or only the one step interaction. So I can, this is the original matrix. And after that, I can add the two-step interaction. And here there is some analytics that has been really hard to compute because basically, I don't go too much in detail in that. We had to look for groups of genes that are strictly connected concerning some kind of diseases. You can see we have bad words here, carcinoma and so on, and we have the genes corresponding. The basic idea is that this kind of disease is connected to that genes. They can reduce it. And they can concentrate only on a subset of genes. And here there is something that this is easy somehow because it's something that we have this information in the sense that someone, some doctors classified the genes associated to each of this disease. But here there is something that is about the top 5 intersecting genes that are looking with the genes with a strange pattern among them, this of similarity. And these top 5 have been computed exploring a very huge solution space with our server working for 2-3 weeks without stopping to select this subset of genes that they share some capability. After that, after you run the analytics, you have this interaction that allows you to filter and to observe the story. But however, concerning our point in this moment, what I want to stress is the way of representing a network using a matrix, and to show you that you can encode different. This is a strong advantage because the square are really little, but you have a lot of room for encoding colors, or if you want even numerical information or additional story on it. Something that is not easy to produce on a network represented in this way. The other way around, people is not in love with this matrix representation. They don't understand the graph. You don't see, you see cluster. You see here there is a strong cluster. This is the result of the analytic. You see here there is a strong connection among them. This is symmetric. This is first order connection, and this kind, there are some genes here that are strongly connected each other. However, we can be back to just a moment to PowerPoint. Now you have a better idea of what is a adjacency matrix. And here this is the story. Also, this social network story has a past, started in 30s, in which images were drawn by hand. On the 50s, some computers started to compute automatically the points and line position. The graph drawing research story started, and now after that the increasing of the computation put give the possibility of having personal computers display images and of a network on monitor with colors. This is not so long time ago, 50 years ago, more or less. And now in the end of the previous century, we have the web, and now you are acquainted with having, as we saw before, force-directed placement, simulated annealing under Java or on the web. But where the story started in 30s with Jacob Moreno, that he got the idea that to represent something, we have first to visualize. Now it is old-fashioned, this sentence. It is obvious. Now it is obvious. We are talking about more or less 90 years ago. And one of the most famous drawing, you saw it during my class, is the social network about boys and girls. Boys are represented by triangles, girls are represented by circles, and here there is the friend relationship. There is a line between two elements representing that this is friend of this, and that show clearly how that we have two clusters. Two clusters of girls that are friends with girls, boys that are friends with boys. There are two girls that are friends with each other, and they don't discuss, they have no friendship with the other, they are isolated. And there is a girl here and a boy here that started a relationship, a friendship among them, between them, and they are the connection. And here again is a visual depicting of what we discussed before. Specialized actor, strongly linked actors. This is the idea, simple idea, in which we have a cluster, and these actors are the connection between the two groups. These are isolated people. This is the basic idea. And he started to having the Jacob Moreno formalized that the fewer the number of lines crossing, the better the sociogram. And the graph drawing community spend a lot of time to figure out algorithms for drawing graph that had a good shape, a good, an appealing visualization, and minimizing the crossing, but also the position of the points is important. If we draw this graph, not splitting the two groups, that would be not a good idea. And you can have a multigraph. For instance, here we have still by Jacobo Moreno, we have players of the American football team, and we have the red that means I like, the black means dislike, and note that edge are oriented unless you are represented a bidirectional story. For instance, this person likes this person, and this person likes this person too. In other cases, this is just one way. This person likes this, not the other way around. And you clearly see that there are, and here there is this special symbol that enforces the fact that it is a bidirectional edge. It is in reality, you have two edges here. And you see that there are some people like this player, 5RB, that likes only one person. No, sorry, he likes everyone around, and all of them dislike him or her, I don't know, him, luckily. And putting here in this position make that evident. If I put this in the middle, that will be less simple to understand. And again, that has been done by hand. So basically, in short, Jacob Moreno put some points on the table. He made a decision to using graph to represent social network. He make a decision to use a directed graph, colors to implement, to encode a multigraph, and shapes to have different kind of nodes. And also he put on the table the idea that the location of points, even if they don't alter the structure of the graph, moving this from here to here does not change the graph structure, but makes more confused what here is more evident. All people is disliking him. And here are some variation, really old-fashioned. Another researcher in 40s created something that is called the Target the Sociogram. We are still on the paper. The web was not existing, but this is perfect to representing the likes. The idea is to have several circles, and the more you are object of the your target of the social activity, like likes, the more you are in the center. This is the person that got most of the likes, and let's go toward the border. You go with people having a few and few likes, and people staying on the same ring as have the same number of likes are targeted, have been targeted the same time, the several number of times. After that, in 50s, people moved from hand-made graph to computer algorithm, and in 52, they reported some computational procedure that had imprisoned the points. It was a mess. When I started my research after my degree, I worked with people working in this field after I changed my direction, and I still remember how much it was complex. Devising a nice algorithm for graph drawing is not an easy task at all. Now we have a more computational power, we have more resolution, we can draw the three-dimensional graph. This is, we're talking about 80s, in which you can have that on your screen. In 90s, the web was able to do that. You can reproduce three-dimensional graph or force-directed graph with sequential annealing and whatever. And there have been some classification. This is a nice story. Maybe you are aware, maybe not. What has been called the small world phenomenon, that has been done by Milgram in 1967, and he used some postal means for doing that, sending postcard on USA. And basically, he came up to the conclusion that if you pick two persons in the world, in any country, everywhere in the world, let's say person A and person B, and they use the social relationship. A knows this person knows this person knows this person, till reaching B. The length of this line, it is a maximum 6. So according to this postulate, if you think of the president of USA and you can imagine that if you move, you have to get the right sequence. There are 6 people at maximum in the middle, and you can reach everyone in the world. And this is a part of having a nice, let's say, emotional impact. Put also the definition of this kind of graph. Now we have the term 6 degrees of separation. It is not a wording that has been used by Milgram in his experiment, but is a way for depicting a graph. These kind of networks, they are really composed by a lot of Euclid clusters, and they are really well connected. And the average path between two nodes is about 6 on average. This is the relationship. I know that person in the world, according to this experiment, of course. Summarizing, we have different level to edge. They can be binary. Are you friend or not? You can have this can of course encode a different kind of relationship. This is binary, or yes or no. You can have a relationship with sign, with a sentiment, like 0 indicate I don't care, plus indicate I like, minus indicate I don't like. Or you can have a scale that is something that you can graduate. 0 means neutral, plus 100 means I love that person. In the middle, I am just, I like it a little bit, whatever. And we need the different encoding for these three stories. And we have also the direction of edges, and we can have some relationships that are not symmetrical. Likes, loves, hates are not symmetrical. We can have a direct graph, and we can have a different encoding for A likes B, B likes A, and both of them likes each other. Think to the sign of Moreno. And that is going to produce not symmetrical matrix. And more interestingly, you have a new task. You can look for I like the likers, people that are isolated, like the two girls in the graph before. Or you can have liked and likers. People that is liked by a lot of people, but they don't like anyone. So the arrogant people. And you can have a clustering strategy. We all like ourselves. Is self-supporting communities closed inside the member. And in some cases, nodes and edge may have different types, boys and girls, like friends edge. And you can have a multigraph in the sense that edges are primitive entities, not meaning that you can have multiple edges of the same type between two nodes, typically. But the edges are representing different meaning. And you can have different encoding on nodes and links, different way of defining clusters. And you can have a lot of problem of scalability. And what about dynamic? This is a very challenging problem. Till now, we discussed about static relationship, but think of the friendship relationship on a social network. It changed along the time. And if you have few nodes, it is really simple. But if you have a lot of nodes, it is not easy to visualize the evolution of a network. It's still an open problem. And a lot of you should have a lot of interaction. You must be able to move the nodes around, collapse a hierarchies cluster in the interaction. And a lot of tools have been defined for looking at Facebook, of course. You have also example about geography. Now I am moving towards example of data that may be of your interest, but is not the only idea. This is just because social network is an increasing, attracting solution for visualization. And there is the Aaron Mails dataset that is a very huge dataset. There was an investigation in 2003 from the US Federal Energy Regulatory Commission, and they catch about 200,000 emails in 3 years of time from the employees of Aaron's. The Aaron's have been investigated from something, and this is a very crowded network. Think of all the mails that there are exchanged between this guy, 200,000 mails. And there is also the time from the start of the investigation, no, later on, but what happened in this timeline? When the investigation started in the middle here, what was the reaction of people? Who was contacting who? And there are a lot of visualization about that. You can go to this link and you can see some solution about that. you can see that you have the name of the person, you have the volume of the email that has been exchanged among two people. But the data set is really huge. And it is still a challenging idea trying to go for a visualization for dealing with this volume of data. If you go here, you get some demo or discussion about this Aaron Explorer. This is just an example of solution. The reason why I'm linking this website to give you some inspiration to you. If you want to go for graph, you can get some ideas from here. Here we have an edge with, you remember the classification that we had before. Here you have a numerical value encoded here. And be back here. And here there are other visualization, just the straightforward visualization of nodes and edge. And with color that you see that if you have the nodes big enough, you can try to encode something on it. Incoming, outcoming. And senders, you can see someone spreading mails, or we have collectors of mails. And here there is another example, an application. It is old-fashioned, not working very well nowadays, but just maybe I have something running on my screen somewhere. This is the Java application. This is the idea of this tool. I just uploaded their data. It is just a friendship relationship. I think you can enable community. You have some analytical here that is able to collect clusters of people according to the number of connection. And there is a threshold. Here I'm playing with the parameter of this algorithm. And there is some simulated annealing in the background that is recomputing the position of what I'm doing. And very simple example, a little bit old-fashioned, but makes clear what is the story. And here we have also pieces of information about single person. You can move it, you can change the layout somehow, and so on. Just to give you some ideas, you can play with it. And here there is another data set with that encode. If you go here, there is a description of the kind. No, yeah, there is a. These are the stereotype. This is egocentric. Look at this one in the middle. No, I cannot fix it. Amanda is egocentric. A lot of people is connected to her. And you have a community in which you get some subset of people that interact each other. You can see here the connection. And think of the analytics you need and the metrics on the graph that you can use for doing that. And the linkage, path connecting people, and so on. I think that is enough to stimulate your ideas. And you can download the software from that link, and you can play with the demo. And here there is a relation browser by Moritz Stefaner, but this is not usable anymore because it was relying on Flash and it's not working anymore. But it is interesting that it's connected to this data set, that it is really a nice source of pieces of information. You can visit the site. This is from CIA, and it contains a lot of data about the world. Basically, you can go for countries. You have data about your picture, and you have a data set, and you can get a lot of pieces of information. This is just like is a picture of a country, but you have other data set here that can be useful or interesting for your exam. And what about the Twitter data? Twitter data is still a challenging application, and here you can get some solution, some visualization for visualizing Twitter, the frequency or whatever. Again, you can be inspired from that. And what about sentiment analysis? This is nice because I have a prototype around sentiment bits. Should be here. Too many. Okay, my mouse is dead. Okay. Let me check. Here it is. Here there is a sentiment analysis on tweet in real time, and the sentiment analysis is very simple. It's just between active and not active, and the test is pleasant or unpleasant, and there is also the confidence about what you get. And for instance, you can go for a research like visual. It works in real time, collecting Twitter from a snapshot, of course. And each Twitter is positioned in a position. You see that most of the Twitter, all of them, are in the pleasant part, and you have this variety of emotion around, and that gives you the confidence. I think that you can go for even having the text of the tweet. And just to stay in the theme exam, okay, we have some tweet of exam in the present part, but some of them are unpleasant, and maybe we can expect this, for instance. Okay, there are some sentiment about the exam result or whatever. Hate. Instead, there are a lot of collision. However, it is a nice interface. Think of the visualization is quite simple, but the analytics is not trivial, and also the data you're dealing with is not trivial. And what about dynamics? Different solution. Here we have this is a graph about, if I remember well, about questions in a class. This is 1 minute the class started. After 5 minutes, after 10 minutes, after 35 minutes, a lot of questions. And the problem that you have a timeline, and in a slice of time, you have some nodes that exist, other nodes that have to appear or disappeared. The same for the edge. And you can try to have multiple graphs, one over the top of the other, but very often, very soon you will be crowded, and you can use some transparency to have this more evident, but it's still really complex. You can use animation for that. And I'm closing here. This is a nice, I really like this. It is about Signor di Anelli, Lord of Rings. And here we have all the characters in the story. And you can see how they interact along the timeline of the book. People that initially are split stay together and they meet other people. You have different stories. And this is for Star Wars or Jurassic Park or whatever. You can go in with this website to get this piece of information. And if you're still looking for other pieces of information, you can ask Wikipedia, and you have a lot of definition, links, whatever. So this concludes this part, this class. Basically, was in the between from teaching something and pointing a solution, giving you some inspirational ideas and so on. And having said that, the class is over. I stop my recording.